Okay, in this video, we're going to go through the Day 2 notes on section 14.1, Permutations and Combinations. So we start out kind of the same way we left off in the other section for Day 1 of 14.1. So look at these notes, and we have 3 people. You're going to sit them in a row of 3 chairs. So how many ways can you arrange them? And just like the other day, you start out by first saying, I'm going to pick one of the 3 people, and they go in the first chair. So here's chair 1. Then pick one of the remaining 2 people. So you have 2 options here. They go in the second chair, and then you place the one remaining person in the last chair. And multiplying those together, you get 6. So that's what you have. Let's do the same thing. And this was very similar to the counting method in last class. So it's not a tree diagram. We're doing this counting method using the boxes, or a lot of times I'll just use straight lines. Suppose you have to sit 4 people, so you can kind of guess the drill. You're going to start out having 4 choices for the first seat. You've placed one person, so you have 3 choices for the next seat. You've now placed 2 people. You have 2 choices for that third seat. And then you want to have just one seat for the last one. So 4 times 3 is 12, times 2 is 24. So given that, you have 24 different ways that you can arrange these people. Think of the same thing for the 5 people, 5 chairs scenario, and that gives you 120. 2 people, 2 chairs, you can kind of see the pattern. And 1 person, 1 chair, there's only one way to arrange that. Okay, so what you notice about the structure behind your answers as you worked each grid? Do you see how the numbers went downhill? You started with the highest number, which was the number of people you were positioning, and you ended up with a 1, and you multiply them all together. Well, doing that, multiplying things like 5, 4, 3, 2, 1, leads us to a discussion of factorials. So when you do a factorial, you have that pattern. So let's talk about that for a second. So n factorial, n is the number of all the people, or the highest number. That's what n is. So n factorial, for the situation where you had 5 people, say, it would be 5 factorial, which would be 5 times 4 times 3 times 2 times 1. Now, on your calculator, there is a spot for factorial, and it will give you that calculation. So you really need to have a graphing calculator for this section. So if you don't have one on you today, you're going to be at a little bit of a disadvantage. So you want to bring a TI-84 or a TI-83 in for this entire section. I think I had mentioned that the other class. The time has come. You need to have your calculator, because you will not be able to do this all by hand. Okay, so clearly this 5 factorial is easy to do, because you're just multiplying things out, and we got 120, I believe, last time. Wasn't that correct? Yes. So in my graphing calculator, I can get 120 a lot quicker. So look at the pattern, and not to be confused, this is the 5. This is 5 minus 1, so that's the 4. This is 5 minus 2, so that's the 3. And then you're going to have times 2 times 1. Okay, eliminate that 3. Okay, so that's how we're doing this. Here are some other examples. So 1 factorial is just 1. 2 factorial is 2 times 1. 5 factorial is a 120. How do you get from 4 factorial? So look here. This is 4 factorial right here, to 5 factorial, which will be in the orange. So how did I get to the next one? Well, they have 4, 3, 2, 1 in common. So I must have taken the 4 factorial and multiplied it by 5 to get to the 5 factorial. Okay, so that's how that works. So next thing, what if you have a fraction and you have a factorial in the numerator and in the denominator? How do you handle that? Well, this is what you're going to do. You're going to take your 6 factorial and expand it, and take your 4 factorial and expand it. So here are your expansions. Then cancel what they have in common, and whatever's left, you would multiply. Now, notice, you cannot do the following. If you have 6 factorial over 4 factorial, you cannot reduce, okay? So this is a big no-no. You have to expand it and cancel. All right, so just be very aware of that. So the same thing will work if you have 2 factorials in the denominator. See what I've done? I have expanded all 3 terms. So 6 factorial is my numerator, 2 factorial is part of my denominator, and then 4 factorial is also part of my denominator. And you end up with 15. Okay, now comes the calculator. So here is where you find it. This is what you have to do. Let's say I wanted to do 5 factorial. So this is my goal. In your calculator, you first put the 5. So write down what you want to have be factored out, factorialized. Put the 5, then go into math. So I put my 5, I go into math, I go across the top to probability, and then I go down to where the exclamation point is, and I hit enter. What shows on the screen is this. And if I hit enter, I will get an answer of 120. So make a note of that and practice with your own calculator. All right, so now we're going to move into our first big topic, and that's permutations. So the most important thing you can remember about permutations is order matters, okay? So I'm going to say, why don't I do this? I can say order is important, and the P in important matches the P in permutation. Whatever it takes, I want you to understand that you have to consider the fact that order is important. So that means if you're going to be arranging something, when you arrange it one way, it looks different than when you arrange it another way, because order is important. And we'll go through more exact descriptions of this. Okay, so now if you have there's 2 options with your calculator. If you have a TI-84 with the more up-to-date, shall we say, operating system, what you end up doing is the following. You would first just go into math. Okay, so I go across to math. I go to math on my calculator. I go across to probability, and I go down to NPR. So I'm looking for NPR. Okay, this is what you're looking for. Oops, sorry. NPR on your screen. When I click into that, this is what shows up. I have a P in the middle. I have a box here and a box here. I take, if we're trying to do this one, I take my 7 and put it here. I then move the cursor and put a 4 here. So 7, move the cursor, 4, enter, and I'm going to get 840. That's with my operating system, the more advanced operating system. If you have just the regular TI-84 that's not been updated, or can't be updated, for example, or the TI-83, then you're going to follow these directions. Okay, you would enter the N, which is the first number, so the 7. Then you would hit math, probability. You would go down to the second item, which is going to say NPR, and then you hit that, and then you enter your R, which is the 4. And then you hit equals, and you get 840. Okay, so same idea with the P10-3. When I do it on mine, I am just going to fill in the boxes. When you do it on yours, you may have to put numbers in a certain order, but you should be getting 720. And if you're having difficulty with any of this, just let me know, and I'm happy to work it with you. Okay, so now, remember we did the box method last time, which is called the counting method. We're going to use the permutation notation from the calculator from now on. So let's talk about this. In a race with 10 contestants, how many different ways can they place first, second, and third? Okay, day one's lesson, we would have put 3 lines, and we would have said, okay, there's 10 contestants, there's 10 ways they can be in first. Then you picked up one already, so you only have 9 contestants left. So there's 9 people that could come in second, and there's 8 people that can come in third. That's 720 possibilities. Okay, because 9 times 8 is 72, times 10 is 720. Okay, so how do I do it with the permutation notation? So permutation says order matters because everyone's assigned a place when they finish. So order matters. So because order matters, it's a permutation. How many people do you have? 10 people. How many places are you going to fill? You are going to fill 3. And so when you put this in your calculator using the math probability option, you should be getting 720. All right, let's look to the next one. And at some point, you may need to stop the video and kind of think about what I'm saying, because I'm giving you a lot of information. The next one says, suppose that Speedy McSpeedster always finishes first. How many ways can the contestants, so we still have 10 of them, place in first, second, and third? Okay, so think about the day one method. We would say, okay, there's only one way, only one person that's going to finish first, and it's Speedy. Then for second place, because Speedy's out of the running, so to speak, there are 9 people that can finish second, and there are 8 that can finish third. So that's 72 possibilities. All right, that's the day one methodology. Now let's do the day two using the calculator. Remember, you still have that first place that you're not really placing. It's kind of done for you, right? So what we're going to do, we're going to say that first person's taken care of. I now have 9 people, and I need to place 2 of them because I just need second and third. So I'm going to say 1 times P92. And so when I enter that in my calculator, so I'm looking for P92. So I should be getting 72. So let me just check on that in my calculator. And I need to put a 2 right here and hit enter. And yes, so I get 1 times 72, which is exactly what I got when I did it with the day one way. So I'm bridging you to this new way. You have available the alphabet blocks A, B, C, D, and E, and they are placed in a row. How many different arrangements could you have? Okay, the day one methodology, and I'll change color since it's another example, is you have 5 blocks. 1, 2, 3, 4, 5. There's my 5 blocks. And you put the first one down. Now, does order matter? You have to say yes, because the blocks have different letters. So it's going to look different depending on what order you put them in. So for the first spot, you can choose from all 5. The next spot, now you only have 4 to choose from. 3, 2, and 1. Okay, so what does that look like in terms of day 2? Well, it's a permutation because order matters, and you have 5 blocks, and you're going to place all 5. Okay, so on my calculator, I'm going to say 5P5, hit enter, and I get 120. I should get 120 either way. All right, now let's put some other requirements in place. How many arrangements can end in C? Okay, so let's look at this in terms of the day one. I have 5 blocks. The last one has to be C. I can only do it one way, by using a C. That means that C is unavailable for the other 4 positions. So I start out 4, 3, 2, 1. All right, let's do that with day 2 methodology. I have the ability at this point to really only place 4 of the blocks because the other one is placed out of my control. So let's see what I get there. So if I do 4p4, because again, it's a permutation, order matters, I'm going to get 24 ways to do it. Will I get the same here? 4 times 3 is 12. 12 times 2 is indeed 24. It matches. Okay, on to C. How many arrangements have the form? So blank, and then I have to have an A. Blank, I have to have a B, and then blank. There's only one way to have an A. There's only one way to have a B. So I basically have taken 2 blocks out of circulation. Therefore, I have 3 options here. I have 2 options here, and I only have 1 option here. That's going to just give me a 6. Why is that the case? Well, because if in terms of permutations and today's reasoning, I really am only positioning 3 blocks. And then the other 2 spots, I am forced to have an A or a B there, so I don't have the ability to position them. So on my calculator, I'm going to go back to my probability again, and I'm going to put in 3s and 3s, and sure enough, I get 6, which matches. Okay, look at this next example. How many ways can we arrange the blocks so that they begin and end with a vowel? Okay, so let's think about this. This is the beginning. That's the end. So the beginning has to be an A or a B. Since both are available, A or an E. Lost my head there. A or an E, because those are your vowels. Since they're both available, I have 2 ways to make this happen. So I'm going to say A or E also for the last, but I've already positioned the first one. So let's say if I put an A here, I have to put an E here without any choice, because now my A has been used up already. So there's only one thing I can do here. Okay, so I've taken 2 blocks out of circulation. So this is going to be 3, 2, 1. Okay, so in terms of how I'm doing this using today's lesson, I have 2 options here. I'm going to then use my permutation, and I have 3, and I'm going to place 3, and then I have 1 option there. So what am I going to get? Well, let's do it on the line method. 2 times 3 is 6, and 6 times 2 is 12. And let's make sure that we're getting the same thing here. So I know that 3 plus 3 is 6. So if this piece is 6, and this is 2, and this is 1, I'm also getting 12. So that makes sense to me. Okay, example 2, you may need to go back over that because it is a lot to think about. Okay, now we're going to up the ante a little bit more. This is a little bit more complicated. So let's do this together. There are 6 different books arranged in a row on a shelf. How many different arrangements could you have? Okay, first off, the way we did it day 1, we would say, okay, 1, 2, 3, 4, 5, 6. This is 6, 5, 4, 3, 2, 1. So I'm basically having 6 books, so different books, 6 place 6. Okay, and what does that end up being? So let me just put this in my calculator. And it is a 6 and a 6 on the other side of the P. And that ends up being 720 positions. Okay, I'm going to be able to place them all. Okay, so then this next one you're going to have to think about. In how many ways can two of the books, A and B, be together? Okay, so you can have, let's think about this. You can have A and B in positions 1 and 2, so have it be AB, or in positions 2, 3, or 3, 4, or 4, 5, or 5, 6. So that's arranging them as A, B. But then can't you also arrange them as BA and do it in those same spots? So I have 5 ways to arrange them times 2 other ways if I just reverse it. So that's 10 ways to have A and B together. Now, I still have 4 other books. So I'm going to have to take the 4 other ones and arrange them. And so that's a permutation, and that's 4. So what do I end up with? 5 times 2 is 10 times 4 times 4, which was 24. So that's going to be 240. So this one is one that has to be thought about in this way. This next one is also a little bit tricky. In how many ways, in how many arrangements will A and B be separated? Don't do more work. We already know that there are 720 ways to arrange these books, right? From A, let me just do that again, 720. And there is 240 ways to have them be together. So therefore there must be 720 minus 240 ways to have them be separated, which is 480. Okay? So again, don't do more work. Build upon what you already knew. Okay, so we're going to complicate things a little bit more. So far in these permutation arrangements and the problems that we've done, you had distinct items. The items involved were all different, and therefore it looked different no matter where you position them. Notice what happens next. Now we're going to talk about what if some of the items are alike. How do you form distinguishable permutations? So, for example, if you are trying to plant or place flowers, Iris is planting 11 colored flowers in a line. In how many distinguishable ways can she plant? Okay, so here are the copycats. She's got 4 red. She has 5 yellow. And she has 2 purple. Okay. If they were all different, we would have said she is going to take 11 and place 11. But some of them are going to be indistinguishable because whether you have a purple purple or flip the order, it's still going to be purple purple. You're not going to be able to distinguish. How do we reduce our number then of permutations so that they're all distinguishable? You take your duplicating ones, which is 4, and have it be 4 factorial. And I'm going to highlight that in yellow because that's tied to the red flowers. I should have probably done different colors, but that's okay. Then you have 5 yellow, and I highlighted in orange. So we're going to do orange. Oops, sorry. I want a highlighter. Here's my orange. Then you have 2 purple. So this is going to be 2 factorial, and I'm going to use the purple for purple. All right, that's what we have going on here. Now, in order to understand this a little bit easier and to input it into your calculator easier, we're going to make the 11 factorial. That's equivalent. So this is what's going in my calculator. Now, you have to have it be a fraction. So if you have the ability to get a fraction bar and I do with my updated system. So if I say alpha y equals, so alpha y equals, I have the option to choose ND, and what it will do, it will give me a numerator and a denominator. And when I do that, I'm getting a box here and a box there. If you have that operating system, you can do that. If you do not, you're going to have to use parentheses wisely. So what will you do? You would say, okay, big parenthesis, then do 11 factorial. So on my calculator, to get 11 factorial, I go to math, I go across to probability, and I go down to 4, and that's factorial. So I want to make it 11 factorial. So I write the 11 first, and then I do just exactly what I just said to do. Okay, so that's 11 factorial. Okay, so then I'm going to, if I have to do parentheses, I am going to, let's think about this. Okay, you could just close these parentheses, and then you're going to do your division sign, and then you're going to do an open parenthesis, and you're going to do 4 factorial, 5 factorial, 2 factorial, and close that parenthesis. That will have your fraction be the correct way. Okay, so I'm just going to do this on my calculator. So I type in a 4, then I go to math, and I go across the factorial. After I go to probability, okay, I've done that. The next number is 5, and I go to math. I go across the top to probability and down to factorial, okay? And then I do the last one, which is 2, and that's going to end up being math, go across the top to probability, down to factorial, and I'm done, and I hit enter, and I get 6,930 ways to have distinguishable permutations. Now, what if I had all different flowers? If I had all different flowers, what do you think is going to happen? Well, 11 factorial with 11 different flowers is a much, much bigger number. Okay, so that would have been 39 million plus. So when you have things that repeat, look what happens to the number of permutations. It reduces it. So the distinguishable permutations are this number. Okay, if I had 11 different flowers and I didn't have repeats, it would have been this number. Okay, let's do the same thing with this word. Find the number of distinguishable. So here again, the tip-off is distinguishable. When you see that word, that means that you must have things that are duplicates. And you should think, I'm going to have a fraction. Okay, how many? Find the number of distinguishable arrangements of all the letters in the word marmalade. Okay, how many letters are in marmalade? If you count them, you should get 9. That's your numerator. What's your denominator? Well, let's see. I have 2 M's. I have 1, 2, 3 A's. Nothing else repeats. So I'm set. So when I plug that in my calculator as a fraction, so this was again my M's, these are my A's, I get 30,240 distinguishable permutations. What if I had a word that didn't have any repeats? What would that be? So let me put that in my calculator and we'll figure it out. So I want to do 9 factorial. So if I didn't have any letters that repeated, I would have had 10 times, more than 10 times as many arrangements. Okay? So the key is repeat. When things repeat, you need to account for the repetition, and that reduces your number, and that should be your tip-off. You're going to have a fraction, and the end result will be the distinguishable permutations. Okay? All right, that's the end of permutations. Permutations, order matters. Let's go to the next topic. Combinations. So combinations are when you are just selecting groups and order doesn't matter. Now, the word combination, you have a combination lock on your locker. Your combination lock is not a combination in the math sense. It is a permutation because order does indeed matter. Okay, so combinations, don't think about your lock. Combinations are when you have groups and order does not matter. Consider the following scenarios. 3 students are selected from the class to each receive $5. Okay, does it matter in what order they are chosen? No. Since order doesn't matter, that is going to be a combination. As opposed to, and we'll change my highlight color, 3 students are selected. The first one chosen gets $10, the second one $8, and the third $6. Order matters. That's an example of a permutation. Okay, so let's see. I assume that you would always want to be the one of the 3 chosen, but assuming that you were chosen, would you care what order you were chosen in scenario 1? No, you wouldn't care. This is a combination. You're all going to get the same amount of money. But in scenario 2, the order does matter. So understand the difference. Okay, let's look at another one. 3 people are selected to be on a committee. The first person chosen is named president, the second chosen vice president, and the third is treasurer. If that is the scenario, then order matters. So for this guy, I'll make it orange. The first person chosen is president, the second chosen is vice president, the third is treasurer. That is a permutation. However, now assume that there are no assigned roles and you simply are chosen. What is the difference? Well, let's see. If there's no assigned roles, I'm going to change it to yellow, and you're just in a group, that is a combination. That's how they are different. So you want to be able to distinguish what you're talking about. Is it a permutation or a combination? Because what you do from that point forward will give you different answers, okay? So combinations are when you're just part of a group. The second they assign titles to participants in the group, it becomes a permutation. Okay, now, I didn't want to talk about this big formula for permutations. This is the actual formula. But I'm never going to ask you to use that formula for combinations. And notice up here, I'm just going to slide up for a second. This was the big formula for permutations. You can compare them both and see the difference is the R that's in front of the denominator. So right over here. Okay, so that little number R, so that little letter R, this is the difference between combinations and permutations. But we're going to always use the calculator. So you're going to be using these inputs. So when we found permutations, we went to math, we went across the top to probability and down to the second spot. If you go down to the third spot, you will see NCR. So we are now looking for NCR. Okay, N is always a number in your sample, and R is what is either placed or chosen. Okay, so I'm going to press my button, and I'm going to put 7-4, and I should be getting 35 here. So the way I say it, when I do a combination, I say I have 7, and I choose, see the C is the same as the C in combination, I choose 4. So here I have 5, and I'm going to choose 3. So again, I'm going to go back to my calculator, and I'm going to do the 5-3 combination, 5-3, and I get 10. Okay, so just for contrast, look how I word myself now. I have 7, and I place 4. And when I place, order matters. So I'm going to go back to my math, go across the top, and I want to compare the numbers. So I'm going to go to NPR, and I'm going to place a 7 and a 4, and I get 840. So compare those two numbers, 840 and 35. So when order matters, you have more possible placements, okay, than when order does not matter. All right, so let's see if we can do these examples. And we're just about done, so just hang with me. You can answer any 3 questions from a total of 4 questions on a test or an exam. In how many different ways can you select the questions? Okay, order does not matter. Order does not matter in that situation. So hopefully you understand that. So I have 4, and I'm going to choose 3. So when that goes in my calculator, I'm going across again, math, probability. I go down to NCR, and I put a 4 and 3, and I get, there are 4 ways to do that. Okay, and what I said was 4, choose 3, and I use choose because choose tells me it's a combination. What if you were selecting 12 or 14 questions? It still is the same scenario where order doesn't matter. Put that right there. If I can just place it here. Maybe not. Okay, let's try that again. So I'm going to circle this, copy, copy, paste. Okay, order doesn't matter. So I'm going to have 14. I'm going to choose 12. Okay, so 14 is in front of the C and 12 is behind the C, and that gives me 91 ways in which to answer those 12 questions. Okay, next example. In how many ways can a committee of 3 be chosen from a group of 12? Okay, so committee. When you see the word committee, I want you to think combination. Nobody has a special role. They're just in a group. So I have 12. I'm going to choose 3. Okay, so in the calculator again, my sample size is 12, and my selection group is just 3. And that gives me 220 ways to choose. Now, if instead you have a situation where when you're making your choices, look what happens. You get labels associated with the 3 that you chose. So order is going to matter there, because if you're chosen first, you're department chair. If you're chosen third, you're technology chair. So order matters, and this is a permutation. So I'm going to say the same situation. I have 12 faculty members, but I'm going to place 3 because order matters. Now, what do you think is going to happen? If order matters and you have the same N and the same R, your possibilities are going to go up. And that's exactly what happens if you put it in the calculator. Okay, big things to remember. Permutation goes with position, priority, placement versus combinations, committee, collection. Let's see if we can figure this out down here. Okay, being on a team, that is a combination. Being in a group where each member has a specific title, that is a permutation. Being part of a group of 20 ticket holders selected to sit in the club seats, Okay, everyone sitting in the same seats. That is a combination. Being part of a group of 10 selected to receive prizes of different, okay, so different dollar amounts. So different dollar amounts makes the permutation, specific title makes the permutation. So I'm going to make that also yellow. Okay, so that is the lesson. So again, you may want to go back over this. You absolutely want to practice doing this on your calculator because that's how you're going to get good at what you're doing.